returning to very, very specific places at very, very specific times and have to navigate in a way that's even more complicated than what the airplanes have to do. And there are a lot of explanations for this, but no one's really solved the puzzle. And it turns out that this phenomenon right here that we're observing is on the cutting edge of this interaction of quantum mechanics and biology. Tristan, would you care to take a look at this? What's going on?
I'm looking at it. Well, we're seeing here two geese that are migrating. I hope. I don't know. They're flying. So, and the amazing thing is they don't just go back generally to the area they came from. They go back to the same spot. So they move thousands of miles, and then they go back to the same spot. They do that without a GPS, as far as we can tell. And they do that with bird brains that we generally don't think about as particularly intelligent.
Now, when you say they do it without a GPS, it means they're not interacting with some database that would reside on a satellite or interacting with some other appliance that would deliver in real time information to them on where they are in space. They're got to doing it some other.
Yeah, so the GPS is really sort of cheating nowadays with navigation because we have the satellite, it gives us our position and so on. This is really talking about navigating with a map and a compass. And so in the old school way, if you're hiking and you have a map and you move things around, that's really what we think they have. And one of the compasses, they have multiple compasses, but one of the compasses is a magnetic compass that they possess. And that's actually, it's an interesting story how that was found out. It was in the 1850s, so there was a scientist who just sort of wrote this in almost poetic language. Maybe even birds have this compass that allows them to find their ways. And then people in the 1930s tried to glue magnets on birds to see whether you can confuse them. And that was very inconclusive in the end of the day. And it was only in the late 1960s, early 1970s that Wolfgang Wilczko actually made the definitive experiment that we now all believe is true. And he was actually studying whether a bird in a little cage would behave the same way as if it's flying. If you take that goose and put it in a cage, maybe you use a smaller bird to make your life easier, would it also go north and south in the respective seasons? And he found yes, but he also noticed that some birds in metal cages behave differently. And so then he started to look at magnetic effects. And what he found is that if he turns the magnetic field, which he can easily do, so that magnetic north points, let's say, to east, these birds will go east instead of north. And so he could turn them whichever way he wanted. And so that's a very beautiful lab experiment that has been done in the early 70s, has been reproduced many times.
But it's one of those experiments that solves something, but actually suggests a much greater mystery. I mean, there's no compass, and the mechanism for how the bird might be detecting north, south, east, or west, either neurologically or in some even more mysterious way, is not well understood. What were the experiments and investigations that began to look at some explanations?
Well, it's the behavior. So we see clearly that they can detect the magnetic field of the Earth and they can get directional information from it. So that's clear. What we cannot do is to point to an organ and say, this is the magnetic organ. I mean, even if you don't fully understand how the eye works, you know that it's involved in vision. If you don't have it, you can't see it. But we can't point and say, this is the magnetic organ. So the experiments, we're still in a phase, I want to make very clear that we don't know how that compass works. We have various ideas that are out there. That's where the physics comes in, because it's actually not that easy to detect the magnetic field that is so weak as the geomagnetic field. It took us humans until like 1100 or so to figure that out. So we've been around for quite a while. And
one way we detected it was with a needle in water on cork.
Exactly, like a lodestone, and then you have this mysterious force. Maybe it's a precursor to quantum mechanics. It was weird and so on. But essentially,
I like it. Go with that.
It's one idea that you have a little compass needle, but that's not the quantum. The quantum idea is coming from looking at particular chemical reactions where, and that was maybe a concept we should have discussed before, and it's a spin of another chemical. Essentially, as a spin, as a charged particle moves around its own axis, it's a moved charged particle that creates a magnetic field. So you can think of a spin in some ways as a little magnetic needle. But unlike a magnetic needle that just turns north and stays there, when you try to realign a spin, it actually evades that and makes this funny movement like a tabletop when you go around. And so imagine you have these tabletops. Normally these electrons like to be in a way that they cancel the effects of each other. rip them apart, you take light and you move one electron to the other side, you create a state that suddenly becomes sensitive to magnetic fields because it has this coherent quantum nature. And if you have this particular state for a while, you can actually detect effects.
So if you could figure out in your bird brain how to, for a few moments, when you needed to detect a magnetic field, how to separate certain particles with spin from their molecular prisms where that spin doesn't really matter. If you could figure out how to do that, you might have your detector.
Yeah, that's an idea. And then if you have that idea that Paul is talking about, that you isolate, so that you have that prism and it's not totally disrupted and broken into by all kinds of other things that are interacting with it.
So are there any molecules that qualify? Any substances found in bird brain that could actually do something?
Well, in fact, I mean, this reaction that you absorb light and then transfer an electron is a very basic reaction. So the key reaction for this, you can create states like that are magnetically sensitive. Now, the question was, one of the things is, in order to absorb light, you need to have certain kinds of molecules, light absorbers, and they don't exist. There aren't that many around that absorb normal light. And so chlorophyll's do it, but we don't think that birds are photosynthetic. And the only molecule that we think of at this moment is called tryptophans, blue green light photoreceptors, tryptic chromophore. The name comes because even blind people get jet lag. And so the idea was that there needs to be another photoreceptor in humans that tells us it's light out there. And so it was called the tryptic chromophore, the tryptic light absorber. And ironically, it turns out that the tryptophan that was found is indeed in fruit flies. It tells the day and night, not in humans. That's being a different one. So now it's a complete misnomer, but it's a new molecule that has been discovered in the late 90s, and this is one candidate.
So cryptochrome does exist in birds?
It does exist in birds. It exists in interesting places where I would like to have it for a magnetic compass, like the outer segments of ice, where the blood water.
So in theory, and again, has anyone proved that this is the case, or is this like an interesting supposition?
There's, I would say we have clues. It's not real proof. So what you ideally would want to do is you take a migratory bird, you take out the cryptochromes, you show that the compass doesn't work anymore, and then you reintroduce the cryptochromes, let's say in this ice, and then the compass works again. That would be a beautiful experiment, but you can't do it because we technologically just don't have the tools genetically to interact.
Do we think that the cryptochrome exists in some specific organ that's involved in this compass, or is it part of the photoreceptors that operate the eye?
We think that this mechanism's basic idea is that actually the magnetic field is an indirect effect on light sensing. It could be really be an indirect effect on vision. If you modify all the vision receptors act, whether it is at the very first point, whether you hijack the vision in the later step, that's a detailed question.
So something about the light hitting cryptochrome releases these photons and the particles with spin. The bird makes some sort of detection of the magnetic field and then modifies its course accordingly. Paul, does that sound plausible?
Yeah, so it's also it's electrons. It's intangible. These things are spinning in the slightly different because they both feel the Earth's field, but the other one feels
So the photon creates the intended pair.
The photon comes in and creates this separated and then that's right, when they merge again and release the energy, whether they're on one step or out of step, depends on how much release so the neurotransmitter is released. So the bird will literally see the magnetic field. And that was the
That was the basic idea, and the light is there actually to provide order in the beginning. Light is a lot of energy in a biological system. So when you know that, if your room is dirty, you need to spend energy to make it clean, right? And that's a basic law. If you want
You
order,
know that? You all know that?
if you want order, you need to spend energy, and light provides a lot of energy, so you can create a state that's very, very ordered in the beginning. And that's really the trick to this. You have something that is extremely ordered. And then it takes time, that from your room as well. It takes a while until it, gets back to its normal state and it gets disordered. And so if you have this reaction going fast enough so that you don't have time for thermal fluctuations and all these movements to disrupt that state, you get a state that's magnetically sensitive. And then then there's another trick that you save that state away, so to speak, in a hard drive that then remembers that state. But that's sort of a detailed step.
Right. I would say that in my family, my kids' room cleaning is not a quantum effect; it's more glacial.
Maybe you should try the quantum nature, and maybe it gets better.
Seth, how do you evaluate